Hello and welcome back. It's John. Today we'll be talking about string methods in Java. So with string, we'll do a quick overview of primitive versus a reference. Primitive data types. So we've talked about this maybe briefly before, but so primitive variables store a single piece of data. A reference stores a memory location that points to a collection of data. And what I mean by this is, let's say there's a container here, and this is a primitive data type, we'll say P for short, like int, and we'll say A. So A is an integer that holds one value. Now this value could be fairly long, but it holds one value and only one. You cannot at any point decide to store this 10,000 alongside 5,000. That is not possible with a primitive data type. However, with reference data types, what you're doing is you're saying there's a bunch of like-minded data types all in a row, and all you want to know is where the first one is, and then you can get to the next ones. So your data type is closer to a pointer, which, if you think of it, is an address like a class, array, functions, things along those lines. All of them, they point to a location, and then they use this location to tell where everything else is. And that's a reference data type, which points to the address, which can store then point to a collection of data. Now, why are we talking about this? Because string is a class, meaning when you create a string, this is a reference to the beginning of a char array. Fortunately, rather than dealing with that array directly, there's many string methods which help us along our path. So string concatenation has been overloaded, so it works the same way as a char. So if you want to, also this is where the plus equals comes into effect, because plus equals will add on more and more to your string, letting you add more and more to the string. But also, the string has a char at. And with this method, the char at will go into the index that you input here and pull that specific char and return it. This can help when you're looking for input from a user or input that you want to later record on a file, because sometimes you want to know the specific letter or character that's at an index, and that can be a little troublesome to do if you don't have that. Also, in tandem, there's a dot length for your string, which will return the length of the string. Now, one thing to be careful of is that it does return the number of items that are in the string. And so if, let's say you have 5 items in this, it's 0 index, meaning 0, 1, 2, 3, 4, but it returns 5. And so one thing to always remember is, because of the indexing, you have 5 items, meaning you would actually have to minus 1 for the last item, because the index here is 4, not 5. But dot length does help a lot in finding out how long your string is. The other thing to think about is comparison. So the equal equal compares two primitive data types. Now if you wanted to, you could overload it to compare two reference types, but as its normal state, it compares two data types. Meaning, if you have an int, this will be able to return an expression of true or false, right? But what if you want to compare two strings? The problem with this is that it's trying to look at it as a primitive data type. So we'll look at the address, if it runs at all, which hopefully it shouldn't, but if it does, it'll look at the address. Hopefully your IDE will catch it and compare the addresses, which shouldn't be the same unless these are the same string, in which case it will return true if they're the same address, and then false in most cases because their addresses won't be the same. But that's not really what we're looking for. What we want to do is do something more along the lines of comparing an actual string of characters. Like let's say I want the user to input hello for a command. So how do I tell if the user input is the same as hello? Well, we have a equals function, so we can go ahead and say user input, and we'll just say this is a string, user input dot equals hello. And this here will return true or false on whether or not the input actually equals this. It'll run through every character comparing H to index 0, E to index 1, and so on and so forth to make sure all the indexes match and give you a result. However, they do add one additional quick functionality, which is ignore case. So one thing to remember is that this is a case-sensitive language, meaning that if the user input is not precise, then your command won't work. So you can do an ignore case and this will go ahead and look into string 1, which we'll say we've already declared to equal hello world. Just hello. So if the user were to input hello or any other denomination or permutation, that this all is equal to this, which is quite nice for a user because sometimes people aren't as precise, but it can help a lot to look out for the user just a little bit in equals ignore case. And this would allow you to do a lot of commands, a lot of, in particular, like passwords. You could use passwords for this, because if the passwords are equal, then turns true, then go into and log in equals true. And if it returns false, then log in remains the same, and maybe return message that back to the user saying that it was false. And likewise, this would hopefully go to a different screen, which would then display to the user, so then they know what's going on. But just as a quick recap, so we have strings, which are reference variable types, not primitive, because primitive can only hold a single data type. And they concatenate in the same way that chars do, but they also have a plus equals, because then you can add into this string and make it longer. They have the same, one extra thing, they have the same escape sequences. Tab return new line as chars. They have a char at index, a length equals, and an equals ignore case. They have some more, but these are the fundamental methods that you're going to be using for your strings, which will let you do a lot of quick algorithm work and solve various different problems. And yeah, those are the basic string methods. And also remember that this equals here is not the same as this comparison operator here, because this one only accepts two primitive data types, and if you were to try to input a reference, at best it would compare addresses, which does you no good, and at worst it would crash the system. And there you have it. Thank you for stopping by. Hope to see you next time. Bye bye.